I'm Patrick Mueller. I work at NodeSource. There's links there. There's a number of links in this presentation as well. And the PDF of this will be available at the Node Interactive site. Okay, so what I just said happened. Couldn't quite do the full one here, so links again to that the presentation I did last month. Okay, so what kind of profiling are we going to talk about? I can't wander, sorry. Performance and memory. And so performance is how fast your application is running. Memory is how much that precious RAM your application is eating up. For both of these, I'm going to show how you can make use of V8's built-in internal utilities, which aren't really exposed to Node directly, but you can get access to them in various different ways. So with performance, I'll be showing V8's CPU profiler, and memory, V8's heap snapshots. Has anybody played with these before? Okay. That's why I was hoping I could sort of concentrate on this to be a kind of a topic people didn't know a whole lot about, and it's actually really easy and useful to use this stuff once you sort of get set up and figure out how to do it. So we're going to start with CPU profiling. So with CPU profiling, the basic way it works is there's a thing called sort of a profiler, as it's usually called, and you're going to turn it on and then turn it off. And when you turn it on, V8's going to start collecting statistics for you. And the statistics it's collecting are basically stack traces, just like you'd see in an exception trace, this function called that function, blah, blah, blah. It's taking those stack traces multiple times per millisecond, so it's very quick. It's taking them very often. It's pretty low overhead. Also collects source and line number information about the functions that are being called. When you turn it off, then V8 will sort of aggregate all that information and give you a JSON object back that has all the juicy information in it that can be given to an analysis tool. So this is something built into V8. It's not really exposed directly in Node. So to understand how to read one of these CPU profiles, there's some terminology and just kind of understanding what it's doing. This is documented up at Google under their Chrome DevTools information site in a topic called Speed Up JavaScript Execution. The two kind of main things that you're going to want to know, first of all, what you're going to be getting back is essentially a bunch of information about functions that were invoked while the CPU profile was taking place. And for each function, you're going to have these two different numbers. One is called self-time, the other one's called total time. And the difference between them is self-time is only the amount of work that the function did itself without any of the functions it called. Total time takes into account all the functions it also called. So it's sort of important to know both of those, and you get sort of a different, gives you a different feel for what's going on when you see both of those. The tools I'll be talking about all kind of use this terminology. So here's what you would see from Chrome DevTools. And so if you've done any front-end stuff and used Chrome DevTools to debug your website, you're probably already familiar with this tool. But this tool you can actually use with the Node.js profiling tools as well. So there's a way to load a profile that you've collected into Chrome DevTools to have it analyzed. In this particular case, we can see these colored towers here are essentially stack traces. And I guess it's going a little bit backwards, but that parser on header complete is calling parser on incoming, it's calling emit, it's calling emit too. And the width here is the important thing. So the width is actually a time value, and you can actually see these time values up here. And you can see it's sub-millisecond for the most part. And this thing up here is actually, this is a timeline. So this is actually the complete timeline of the CPU profile. And I've narrowed down, you can see right here, this kind of range indicator. I've narrowed down just a very tiny little piece. This application wasn't very busy. It's just every like 3 times a second and wakes up and does something. So you end up seeing these little things you can narrow in on, and you can look at the functions that got invoked. Here I clicked on the handle function, and so we're seeing here some of those values I just talked about, the self time and the total time. In this case, that handle function itself didn't really eat up much time just by itself. But whatever it called, which was next in this case, and whatever next called took up 3.6 milliseconds. And then, like I said, you also get source and line number information, so that can help narrow down exactly where things are taking up time for you. You'll also see occasionally aggregated numbers, like these two here, aggregated self-time and aggregated total time. And what those are telling you over the entire CPU profile, how much did that function take instead of in just this little spike here. So another view, and this is also from Chrome DevTools, is a chart view, and this is letting you sort the profile based on self and total times for all the functions in the program. And then you can see these little expander buttons here. I didn't expand one, but that can show you other information, like what it called or what calls it. It kind of depends on what the view is. So both of those are very useful little things you can get from Chrome DevTools itself. So I work at NodeSource, and one of the products I work on is called NSolid. It also provides CPU profiling and heap snapshots, as we'll see in a second. And this is one of the views from our tool. And what this is showing you, instead of a timeline, this is showing you really the aggregated results. So this is all of the stack frames over the period of your CPU profile in one particular view. So instead of having to like hunt down the spikes or look at the textual chart from V8, you can actually get a graphical view here. And it works the same ways that the view in Chrome DevTools does, except this works up, like flame graphs normally work instead of Chrome DevTools, which is currently showing it down. And the spikes are calls, so you know, it works up. So this thing called that thing, called that thing, called that thing, all the way up to here. If you click on something, then you'll get some more information about the stack trace, some self and total times, and that kind of stuff. Another kind of interesting view that we have in NSolid is sunburst view. And this is really just the same view as before, only wrapped around a circle. And the interesting thing about this one, I find, is that it sort of exaggerates the widths, which are important, right? The widths, the widest things take the most time. And it sort of exaggerates them a bit, so I find that you almost kind of get a better view of it, although it's not like intuitively, I think people sort of like this view better. Kind of switch between them. Okay, so how can you get these fantastic CPU profiles? A couple different ways. There's an NPM package called V8 Profiler, and it provides an API that you can use to be able to collect these profiles. And what that means is you have to add code to your application to start and stop the profile, and then get the profile information, write it to a file, which you would then load in Chrome DevTools. Another way to do it is with Node Inspector. It has a way of being able to kind of auto-inject some profiler bits into your app when it launches them, and then it can show you those profiles, and it'll show them to you in the Chrome DevTools views that I showed before. Another thing is Strong Loop's Arc project, and then NodeSource with our NSolid product. So I'm going to show you a little demo right now, and the idea here is that there's some kind of a response time problem, and this is a very simple Express app. There's not a whole lot going on here. So let me switch over. So this is NSolid, and here's my Express app with all my other apps running. And I'm going to click on the app here, and we can see we give you all kinds of information about what's going on. You can also see maybe a heap problem here. If I want to get a profile, I just click a button. Sort of tell it how long I want, click another button, it's going to start the profile and then stop it, then show us the results immediately. So this is a tree map. This is yet another view. This is sort of like a view looking down on a city map where the area is actually the important thing. But the flame graph and sunburst are both here as well. And so if I click on something, then I can get more information, and you can zoom in and stuff like that. So these tools are pretty easy to use once you sort of get set up and familiar with how to use them and how to read them. So let's go. So I'm running short of time. I'm going to go right into the profiling memory, which is the other important profiling tool from V8. And so to profile memory you can use these V8 heap snapshots. So a heap snapshot is a JSON file which describes all of the reachable JavaScript objects in your application. So as you can possibly imagine, that's a lot of JavaScript objects. They start, V8 always does a garbage collection before it does the heap, so you'll cut down on a little bit on the size, but the files are quite large. So I think the sort of going thing is to say that the JSON file this thing produces is going to be probably twice as large as the amount of heap you have allocated. So if you have a 100 meg application or an app with a 100 meg heap, it's going to be a 200 meg JSON file. That's a lot of data. It's triggered by just a single call into V8 called heap snapshot. So the important things to understand with heap snapshots are there's kind of two numbers just like there were with the profiling, and even same kind of shape. There's a thing called shallow size versus retained size. And shallow size is just the amount of space a particular object eats up itself, which would typically, I think that might even just be like kind of arrays end up having interesting numbers there. Retained size is all the objects that object keeps from being garbage collected, which would be its own properties along with anything else it might happen to be touching that for some reason are not being garbage collected because it's touching it. So that's actually the super important value right there. So here's a sort of heap map you get from Chrome DevTools. So again, you can load one of these heap profiles right into Chrome DevTools, and it provides a nice analysis tool for it. I guess the state of heap snapshot tools today is basically that you get a list of your objects grouped by their constructor name. So if you have a bunch of different interesting object literals, they're all going to be lumped under object. So it really only shows class instances kind of nicely. So we can see some in this particular case. I actually have one called tag request, which is a class that I had created. In this particular case, I have these tag requests are not very big, but they end up pointing to, so the interesting thing here is that if you click on one of these objects, then you can kind of drill into it and find out who's referencing it and what references people have to it. In this particular case, tag ends up, this tag object is a property of an incoming message object. Anybody know what incoming message is? It's your HTTP request. And your HTTP app, you always say, handle, request, response. The request object is called incoming message. You might not know that, but you can kind of drill through here and you'll end up seeing incoming messages highly associated with other things in requests like sockets. Okay, so, and then one of the other interesting capabilities is to be able to take two of these heap snapshots you've taken over time and do a diff of them, and that's really kind of the tool you can use to identify a leak. So I'm going to do a demo of that right now. And in fact, I believe I have some snapshots already loaded, so I don't have to take time to do the snapshots. But if you want to take snapshots, it's going to be very similar to however you did the CPU profile Like in NSolid, you're just clicking a button and it gives it to you. In this case, I already have this. So one of the views here is typically you're going to be in one of these containment or summary views. But if you have multiple heap snapshots open, you can open this comparison view. And that's going to show you, in this case, I don't know if I can zoom this. It doesn't really zoom all that well. But what you'll see here are these columns that are telling you how many new objects got created, how many got deleted, and then what the delta is. So in this particular case, got a delta over time. This thing added 2,000 objects, and I did the heap profiles just like a minute apart. So that's not good. Not much stuff actually went down. Compiled code went down. That's actually not good. You want to see more compiled code? But there's more of these incoming messages. So looking at a heap snapshot like that, you're basically going to say, once you realize that incoming message is actually HTTP request, is that, oh, I'm leaking my request somehow, right? So this is sort of the easiest way to find a memory leak. All right. So let's see if I got time for anything else. So a couple profiling tips. I think I went through a bunch of these already, but with profiling, generally you're always going to be looking for width of things. It's very intuitive to think that the height of these stack traces is somehow indicative of a performance problem, but that's not necessarily the case. Maybe indicative of a complexity problem in your code. If I used to do Java and we'd have stack traces like this, and so you get big stack traces, maybe you need to be worried about your code structure, but doesn't really say anything about performance. It's always the width. To script a web server, it's actually fairly easy. You can you can start a profile, run some kind of load test, and then stop the profile. If you have some way of scripting your profiles, and usually there's ways to do that. Kind of weird, but V8 has a great optimization called inlining, which will take small functions that are called a lot and just go ahead and move the function body into the thing that calls them. Unfortunately, those functions then disappear from profiles. So if you're looking at a profile and you're missing some functions should be there, you can use inlining to get those to come back, and they won't get inlined. On the other hand, it's great optimization, so you're kind of losing out on the optimization while you're doing profiling. So kind of a mixed bag there. Again, profiling memory, best way to find a memory leak is to do 2 heap snapshots and then use the compare function in Chrome DevTools. And then that tag thing that I showed before, actually I could go back into the code. This is kind of a little trick that I use if I don't know exactly what might be leaking, but I think I might know what might be leaking. So in this case, I have this class called tag request, and there's no body. It's just going to be a 20-byte object that's allocated. But I end up attaching it to the request. And then you can create as many tags as different things you kind of want to measure. Then when you're going in and looking at your profile, you don't have to guess at what request is. You really have no idea what request is, right? So for third-party libraries, you might not know what the classes are. You can just go ahead and tag them somehow, and then look for the tags that you put there. And then you'll know they're associated with that thing. All right. And I think that's it. So any questions? We got a few minutes for questions. Yes? Does NSolid work on 5 yet? Does NSolid work on 5? We do not have a version other than LTS-based versions, so just 4. Anyone else? Somebody must have a question. Yeah? Yeah, that's a good question. Actually, we have, I have some assigned work to figure out exactly what the overhead some of this stuff is, because we don't have a good feel. I don't think that doing this as part of your production at like 10% of the time is going to be the right thing to do. There is some work going on in Node.js working group, tracing working group, where we're talking about providing tracing capabilities that are running full time. And want to come up and talk to me, I can tell you how to get involved in that. That's probably going to be the best approach to being able to do something like that.
Do you have any profiling suggestions for I/O stuff?
So profiling suggestions with I/O, that's tough because that's all mostly stuff that does not get captured by Node. So for that, there's actually part of the async working group. There's some the tracing work group. There's some work going on with providing better async capabilities. So being able to, when an async event gets started and then handled, and being able to instrument that in a very generic way. And so we're thinking that's probably going to be the best approach to doing that. Today, you can try to stitch some stuff together yourself, but that's a tough one. You're probably better with an OS-related I/O perf tool. Anything else, or are we out of time? Yeah? Okay. All right. Thanks.